But we go there for the last presentation today. Remco Offenberg with Allnamics will give a presentation about the reuse of existing foundations and a case study in the Netherlands. Remco, floor is yours.
Okay, thank you, Gerald. Good morning, good afternoon, everybody. My name is Remco Offenberg. I work for the company Allnamics in the Netherlands. And today my presentation is about the reuse of old foundations and how to investigate if the reuse is possible. During my work, I do investigations and judgments of new and existing foundations on a daily basis, especially the old timber pile foundations of the old kennel houses in Amsterdam. Next slide, please. First of all, I want to tell something about why we often choose for the reuse of the foundation instead of replacing. And after that, I want to tell something about the tools we have as an engineer to investigate existing foundation. And finally, I want to show a case of a project in the Netherlands we have been involved in. Next slide, please. So besides sustainability, there are more reasons to choose for the reuse of a foundation instead of replacing. Especially in inner cities, new foundation works can lead to high vibrations. And common construction activities such as large equipment and drilling, they produce ground vibrations which conceivably damage nearby buildings. And the installation of new piles can also lead to pile capacity reduction of the neighboring structures. And maybe there is not enough space left for the new piles, so the existing foundation have to be extracted to avoid installation risks for the new foundation. Limited working area is also a reason to choose for the reuse. In many cases, the working area is limited and there's no space left for the heavy foundation machinery. And in the cities, the old-fashioned infrastructure is also limited. So some of the roads and bridges are in bad shape. And so in some areas, we are not allowed to use the heavy equipment. If we don't have to demolish or rebuild the buildings, we also reduce costs and construction time. And sometimes reuse is preferred or even prescribed. Prescribed in the case of a monument. If a building is a monument, we are not allowed to change the construction at all. So only when we prove the foundation is in bad condition, we are allowed to renovate the existing foundation. Next slide, please. Here's some pictures of the logistics in the inner city. As you can see, heavy foundation equipment in a narrow street. These situations cause a lot of problems. If possible, the equipment nowadays also transported over water. As you can see here in the picture, it's the canal. Next slide, please. What is the challenge of an engineer? The engineer challenge is how to deal with unknown parameters. Our investigation starts with a desk study. We try to find the original designs in the archives, so we have more information about the kind of foundation and the pile loads. What's the history of the building, and what do we know about the pile dimensions, like cross-section and length? If we are lucky, we sometimes find the old installation logs. If there is no information available or not enough information, we have to excavate. We also have to excavate to check the quality of the pile material and to check if the foundation is built as designed. Also important, soil conditions. In the Netherlands, we use cone penetration test, mostly executed inside the building. So we can calculate the theoretical bearing capacity of the existing piles. And another challenge is how to deal with the expected developments for the near future, like the decrease of quality of the timber pile because of dry rot and wood decay. For the quality of the timber piles, the groundwater table is very important. Next slide, please. world famous Tower of Pisa in Italy. Next slide, please. We use these pictures very often in our presentations to illustrate the importance of soil investigation. So not skimping on a design of the pile foundation saves, in the end, money. It also illustrates the importance of good recordings and how and what has been made. Our suggestion for future works is archive as built next to archive as designed. Always nice to show this picture. Next slide, please. The next subject is how to investigate. Which tools do we have as an engineer? Next slide, please. The reuse of an existing foundation needs additional research. We have to check the integrity, serviceability, the quality of the pile material, and in the end, the ultimate capacity of the piles. In our toolbox, we have many investigation options. So as I said, we start in the archives to collect information like drawings, installation records, and designs. And after that, a visual inspection to check for cracks and irregular settlements related to the foundation. Measuring the settlement of the existing building. The vertical displacement is a very good indication of the quality of the foundation. And excavating a part of the foundation to check the quality of the pile material and to check if it was built as designed. And finally, a load test to overcome all the uncertainties. And next slide, please. Like mentioned before, the behavior of the superstructure tells us a lot about the quality of the foundation, as you can see here. Next slide, please. A beautiful picture of the canal houses in Amsterdam. Because this is typical for Amsterdam, we want to keep it like it is. So in this case, the reuse is preferred. And for us to investigate this kind of buildings daily. Next slide, please. Telltales, monitoring telltales. This is an example of the monitoring bolts we often use. If these bolts are measured regularly, we know the vertical settlement of a certain period. And the vertical displacement the vertical displacement velocity is also a very good indication of the quality and performance of the existing foundation. Next slide, please. What do we know about the pile loads of an existing building? Often a misunderstanding, an existing building gives only a permanent load. The only thing we know is the piles have proven to be able to carry the load. And the question is, what is that load? Without a load test, it's difficult to determine. So therefore, we have to perform pile load tests. The test pile has to be representative for all piles, either in dimensions and in previous loading history. The number of load tests depends, for example, on the size of the building and the results of the measurements. And also very important, one test is no test. Next slide, please. What are the advantages of a load test? First of all, it's a performance test of the deep foundation as it is now. It reduces all uncertainties, so we don't have any discussion anymore about pile dimensions, final blow counts, pile integrity, or pile length. The only exception is the future quality of the pile material, like I mentioned before with the dry rot of the wooden pile. A load test is also a proof of capacity and serviceability. The challenge of the engineer is how to extrapolate load test results of the tested piles to all the piles. Next slide, please. 3 pile load testing methods are available. The static load test, a rapid load test, and a dynamic load test. Without an existing superstructure, all the 3 of the methods are an option. But if the existing superstructure remains in place, a static load test is the only option. In that case, we use the superstructure as a reaction mass. Next slide, please. Some pictures. Picture to the left, the superstructure looks okay, and the position of the pile is also okay. So a load test can be executed. Picture at the right, you can see limited strength of the superstructure. A load test isn't an option. The load test will damage the superstructure, and it's not possible to mobilize full pile capacity. So not possible. Next slide, please. The question is, do we a load test, yes or no? Do we always need a load test? For example, I made 5 steps, starting with a desk study and ending with a load test. During the first steps, it may be concluded that no additional load tests are required. Either the piles will not be sufficient qualities or strength. Either it can be concluded that the reuse is a potential option. So we don't always, it's not always needed a load test. Next slide, please. A case study. In the recent years, we have been involved in several projects. One of the projects is an old plant in the Dutch city Leiden. Next slide, please. The complex is called the Meelfabriek. In English, a flour mill plant. The complex consists of 8 national monuments, and they want to reuse the buildings and the foundations because it's a national monument. The statement is to reuse many parts of the building, such as bricks, foundation, concrete floors, roofs, and steel frame. Next slide, please. This is the complex as it should look like in the future or in the nearby future. Not all the different buildings. Next slide, please. The original foundation. The Meelfabriek is an industrial complex comprising several large buildings. Flour used to be produced here with the various types of grain. They brought in by boat along the nearby canals. You can see over here. The mill was founded in 1884, but was closed down in 1988 for economic reasons. And recently, the plant has been redesigned to apartments and housing. So here you can see the old situation and the new situation with the extra floors, additional floors. Next slide, please. The original foundation is on timber piles. The new design leads to higher working loads on these piles, and floors will be added on 2 buildings. It's only on 2 buildings they added the floors. The question is, can the old timber pile be reused, or does the old monumental construction need a completely new foundation? Next slide, please. This is a part of the original foundation layout, 1884. As you can see, all pile groups with a lot of timber piles close to each other. Next slide, please. Besides the original foundation layout, there was no information about the timber piles. no installation logs, no pile lengths. And after excavating several piles, we found an average diameter of 250 millimeters. Because of the diameter of a pile, timber pile decreases with its length, the diameter at the pile toe is unknown. An assumption is a decrease of 8 millimeters per meter. So the pile length is not known, and even with soil investigation, we were not able to estimate the pile length. So we need a load test to answer the questions about the pile capacity and the expected settlement at the new working loads. Some pictures of the load test of the setup. Next slide, please. On these pictures, you can see our load test setup under the existing structure with a hydraulic jack and underneath the load cell, and 3 potentiometers to measure the settlement at the pile top. Okay, next slide, please. So the results of the measurement of the load test. The graph on the left is the force in kilonewton versus time. Here you can see we did 6 load cycles. And on the right, the graph of the settlement of the pile versus the time. You can see 4 lines. The thick red line is the average of the 3 potentiometers. Next slide, please. And the third graph is the settlement versus the force with the load cycles. Next slide, please. In this case, we tested 3 piles. You can see the blue, the green, and the red line, all different piles. The red and the green pile showed almost the same behavior, and the blue pile showed a different behavior. But in this case, it's no problem at all, because you can see this line is the original design load in 1884. And the new design load is between these 2 lines. So there is more than enough capacity available. So it looks like the red and the green pile behave better, much better than the blue pile, but the blue pile is still okay. Next slide, please. So the load test showed different behavior between the tested piles. We have 3 explanations. Because the timber pile is a product of nature and tapered, the pile dimensions will be different, especially the pile toe. A different pile length and a different CPT results as the test on the test pile locations. And in the end, the conclusion was the ultimate test load was more than the new working load. For all the piles, the test load was approximately 2 or 3 times the new working load. All the test piles have been accepted. And the test loads were regarded as representative for all piles. Next slide, please. So based on the 3 load tests, all piles have been reused, especially because of sufficient overcapacity and soil investigation. The other piles were accepted as well. Next slide, please. Conclusions. First conclusion, more than ever, global sustainability requires the reuse of an existing foundation. Sorry, next slide, please. So like I said, more than ever, global sustainability requires the reuse of existing foundation. The foundation engineers have a number of tools to evaluate the performance
of the existing foundation. To reduce uncertainties, load tests can be performed, and a load test can indicate hidden safety and higher capacity due to modern design tools. And last but not least, the reuse of a foundation saves money, time, and of course natural resources. Okay, next slide. Thanks for your attention.